suggested. So it's really about a way of describing deadlines that had a wall clock property to them. And to begin, it's my inspiration. A few years ago, I ran across a means. It was a paper describing contextual integrity and talked about how to enforce the requirement that you send out a privacy notice every year. And so they put together this LTL expression, and I'll give you a little breakdown about what they were doing. And so you've got a couple of magic symbols here. So once you open an account, that implies that in the future, at some point eventually, you will have a privacy notice until you close the account. I've paraphrased it slightly, but that's what they were getting at. And it's kind of clever because it ends up getting that it's going to be sent repeatedly. And the authors said this, and it's true, that it doesn't actually enforce that you actually do this annually. It's just that it's some point in the future. And I actually take a little bit of objection to this even being correct for enforcing what they were trying to do. I put this into new SMV and managed to come out with a trace that was totally legitimate and actually failed this. You're making a face, so I'll definitely tell you later if you're curious. It's really simple and dumb, but that's the point of these formal methods, is that they're very simple and dumb, and so it comes back and says, this objects. But all right, so they didn't enforce the yearly requirement. So I start, I guess, casting around for something, and I come up with MTL, and it adds this wall clock requirement. And there's a bunch of different forms of it, but I have a particular favorite, and it lets me talk about things like this. So this is the once operator. So one of the limitations I used is that I went with past time only, at least for this application, because I'm talking about monitoring things that have happened in the past. I don't need the future time. It does give me a bit of a problem when talking about that recurring thing like annually, except that now that I've got the time limit on it, I can say that it needs to have happened within the last year. And then as soon as it has been a year, that suddenly becomes violated, and I can say something about it. The other thing that's a little bit unusual here is that I'm talking about a really dense time representation. So I'm describing Boolean signals in kind of the FRP sense, before I knew what that was, that there's a truth value at all times. And what I'm dealing with here is sort of a representation that looks like a piecewise function. And so this P becomes true at an infinitesimally small amount of time. So there's some now that it's true, and then it's not true afterward. So it's very much like the event, make sure I'm using the right word, yes, from FRP. And then later I have it going true and then staying true. And this is a kind of funny kind of a transition. It's true right at that moment and then false immediately afterward, no matter how closely you look. The definition of the once operator in that case is something that says, all right, if within the last period of time the input was true, then I will be true. And you can change these, the range on the, whether you include the ends of the intervals. And so I'm using the kind that is inclusive, and so that tends to produce the kind of true now and stays true, and when it goes false, it does so immediately afterward, like you see here. But you could have open and closed parentheses. But another limitation that I placed on the implementation that I put forward for this paper was that this number here must be 0. And this is going backward in time, by the way. So it's from now, one time unit, whatever your unit is, in the input that determines the truth of this expression that's coming forward. So the reason to place that limitation is that it means that I can always determine the truth of an expression right now, and that I can't grow in memory. So basically it's just constant memory as it's churning along, always able to come up with an answer. There are some fun variations where you can set that window a little further in the past, and then you can know the truth in the future relative to now, but you can potentially have to keep track of a couple of them, and I just kept it simple for this time. There's another option historically. It's sort of the inverse, and we are saying that over a period of time it was always true. And again, you can place different inclusions on the edges of the intervals, but this can be useful for things like, of course, when I try to think of it on the spot, nothing comes to mind. But you can imagine something that importantly has to have been true for you to be in a good state. You can use historically, and then if it ever wasn't true within a certain period of time. Just an inverse, I actually tend not to implement that one, and I think really in terms of the other, the once operator, and if you need this, you can do it with a couple of inversions and say that it isn't true, that in the past it ever wasn't true, that P. So all right, I have a scheme for detecting violations. But I thought, well, this is neat. Why not just not violate? Why build the system that says, look, you didn't send a privacy notice. Why not just send the privacy notice right then? It wasn't really that clever of a thought. But how can I describe something that will react to an MTL expression? Some people might answer monitor-oriented programming. I did think this is a monitoring application before, but here, I wouldn't do that. Instead, I would call it functional-reactive programming, which brought me, that's actually thanks to last year's Splash, in which I was introduced to the idea that there was this thing called functional-reactive programming. I spent the year trying to introduce myself to it. I tried to force it on some of my coworkers and found a tool, because we use Java for some of our applications. I found a tool called Sodium that tries to implement it. Its primary implementation is Java, but it does have Scala, C++. It had Haskell, it's apparently deprecated. Rust is supposedly in the works. It's all push-based, which really fit well with my understanding of how to implement the operators from my previous work. It guarantees glitch freedom, which I thought was really nice for something that's trying to monitor logic, that I could just say, if it's going to put an output out, it will be the logically correct value. I don't have to wait for any kind of eventual consistency. And I at least perceived it to be an attempt to put forward the least common denominator of all the operators. As you sort of mentioned, there are a few, 6 you said, things that just kind of ought to be there. It has some of those. I don't know if it actually has 6. I didn't count. But it does, the author of it does really heavily recommend that you follow the functional paradigm. Even though you're in Java and you can do whatever you want, please put out immutable outputs, and please don't have side effects that are going on inside of the operators. So all right, fine. When it came to writing this implementation, and some of this was done before I knew what functional-reactive programming was, it still occurred to me that, hey, I'm interested in this dense time representation, but I don't actually have to do anything during most of the time that it's true. I only have to think about it when it's changing. And so I basically can treat a signal as a series of time-stamped transitions that are, is it true right now? And is it true immediately afterward, infinitely dense time? And then from that, you can compute what it was in between any of the transitions, and it's enough to compute the output. To remind ourselves a little bit, so I'll be going on to how I actually implemented it within Sodium. And my effort was to try to implement this without really making a change to the Sodium framework at all, and just see if I could get it put together, see where I had to do something that was kind of, I don't know, not a good idea, or something I wouldn't want a normal developer to do. And then that was my experience for the paper. So all right, here's what's going on. The key here for the once operator is that whenever the input comes in, it always goes true. It can never go true and immediately become false. So it's always one of these kinds of transitions. And then after some length of time, with no input from the output or from the outside world, it should transition down, and you want that to be timely. So that was the first thing that came up, was that I had to do something that would remember that I had something coming up and then actually respond to it. So there ended up having to be something external to the nice pretty drawing I have here that is a timer that can expire and inject some events. But generally speaking, it was pretty straightforward, that I had the input. It looks for anything that stays up. So that's, I don't know if you can read that at all, but anything that has that next value being true. And then anything that goes down. And if it goes down, then I'm going to add in a timer event in an optional, so it's a Java 8 optional, that gets sent out to something that's going to keep track of a timeout handler, and that's remembering the last timeout handler that was seen. So as these things come through, I'm going to make a quick aside about my diagram, that these guys, the things with pointy edges on them, those were somehow the events, the things that are ephemeral. So the actual up events, these timer handlers, were ephemeral, but they get stored in the square kind, which is in Sodium called a cell. Historically, that would have been called a behavior. And that gives me a place to keep track of it so that I can say, all right, I had an up event, and then at some point it went down. And in the future, so the input has gone down. In the future, I'm going to have that down event. If I get an up event in the meantime, then down here I do a snapshot operation on that. Take the snapshot and send it off to somebody who's going to actually cancel that event so that it won't happen. So that's if I go up and stay up. If I go up and stay back down again, a new timer event is going to come through, and then it will end up in the handler. There's a little bit of cleverness on the output. I don't think it's necessarily worth spending too much time on, but effectively it's just bookkeeping to make sure that you don't end up putting out anything nonsensical like 2 trues in a row, like all true. You can just not say anything in that case. So the things that I didn't like about it, the implementation, are that when I did this timer event, there's a side effect to this piece that actually goes out and puts something into the queue for a thread that I've separately launched that is going to actually issue these timeout events and cause the signal to be seen to go down. And then similarly, this is also making reference to an external entity that it just seemed like it had a smell to it. The other thing that I ran into that I didn't have a way to highlight was that the merge that's provided by Sodium here for the output isn't exactly what I would have preferred that it had been. If there were a timeout and an up, sometimes it's important that those two things happen simultaneously, and Sodium doesn't actually have a very good way of dealing with that. It's not like as if that you're presenting where it would always make sure that you're dealing with tuples. And I think to get this right, I'm going to actually have to implement something that does that job, sort of work around the tool a little bit. But it is good enough that I was able to do one of my goals that I set for myself, which is to say, all right, if Sodium is implementing a least common denominator of all functional reactive programming, and I think it would be good for it to have time, and there are other tools out there, reactive extensions in particular, that already have ways of dealing with time a little bit. Let's see if I can use my scheme to re-implement some of their tools. And so they had a bunch of throttling operations. So that's the kind of thing that you'd use if you had a text window on one side, and then maybe some syntax highlighting. And so you let someone enter for a little while, and then as soon as they stop typing for a little bit, only then do you do the expensive operation. It's not a matter of correctness, it's just a matter of performance. But all right, so I was able to implement it. This is a lie. Sorry. That should be my favorite, not the historically, rather the once operator. So the idea is that as the input keeps coming in, and this is hold, and it will return the last input that made it through. That doesn't matter at all for the example I just gave, but within reactive extensions, they have a throttle last and a throttle first, and throttle last was a little bit easier. So here I could take, this is again the ephemeral kind, the events. I hold onto it, I turn it into a behavior that will hold whatever was the last event that ever came through, and then I just map the input, the presence of any event whatsoever, to one of those little impulsive ones that's true now and then goes false. And then, as I said, this absolutely should have been the once operator, and what that would mean is it's going to keep being true as long as we've received a key press within the last little while, and as soon as it goes false, a piece of magic that is hidden in this line that just basically filters for the down events will sample this behavior and send out an output that contains the throttled version of the events that came in. And that is that. Questions?